All right, for the final page of the study guide, the free response question, we've got a test plane that's flying in a line has a positive velocity. We're told the velocity is miles per minute, and t is measured in minutes. V is differentiable. Okay, that means that acceleration exists for all values of t. They give us certain values of v up here in the table. Okay, so part A says use a midpoint Riemann sum with 4 subintervals of equal length and values in the table to approximate the integral from 0 to 40 of v of t dt. Show the computations that lead to your answer. All right, then there's another sentence. We'll get to that in a second. So let's do the midpoint Riemann sum. So we're going to go from 0 to 40. So that's 40 units of time, and we want 4 equal subintervals. So that means each subinterval is going to be 10 minutes long. So we're going to go from 0 to 10, 10 to 20, 20 to 30, and 30 to 40. In each case, we're talking 10 minutes. All right, and we're going to do a midpoint Riemann sum. So that means we're going to pick from 0 to 10. We're going to pick the number in the middle, so that will be the 9.2, and then from the 7, the 2.4, and the 4.3. All right, so our midpoint Riemann sum will be equal to 10 times 9.2 plus 10 times 7 plus 10 times 2.4 plus 10 times 4.3. All right, this is the miles. All right, because we took the antiderivative of velocity, and velocity was miles per minute, so we're going to go up 1 unit, and that would be miles. This does not need to be simplified. We can simplify it. We do have a calculator available to us, so we bring that in. Get this so the glare is there. All right, so we have 10 times, well, actually, we know what 10 times everything, so it's going to be 92 plus 70 plus 24 plus 43 for a total of 229. So that's 229 miles. And then now show the computations of your answer. Using correct units, explain what it is that we just found. And we haven't really done that much of this with our integrals yet, but you can probably gather what happened here. All right, the plane flew a total, and that's the key word there, a total of 229 miles during the time 0 less than or equal to what do we got? T less than or equal to 40, and it says using correct units, so we want to make sure we give the units for time as well, and that was minutes. So we could have said the first 40 minutes of the flight as well. That would be the same thing as t being between 0 and 40. But the key is that you're saying that the plane flew a total of 229 miles during 40 minutes, specifically 0 to 40. Okay, part B. Based on the values of the table, what's the smallest number of instances at which the acceleration, let me underline that, the acceleration of the plane could equal 0 on the open interval from 0 to 4? Justify your answer. All right, so we're interested in when acceleration is equal to 0, and we know acceleration is the derivative of velocity. So we're interested when the derivative of the given function is equal to 0. Whenever we're interested or asked about the derivative of a function being equal to a number, this is bringing in the mean value theorem, because that's what the mean value theorem really connects. It tells us that the derivative will be equal to the average rate of change. So if we look up at our table of values, we're looking for it to do an average rate of change that would produce a 0. All right, we know that the average rate of change would be the velocity, at some point b minus the velocity at another point a over b minus a. We want that to be equal to 0. Okay, that's the derivative. This is our a prime, our a. A is approximately equal to this right here. So we want a fraction to be equal to 0, which means the numerator needs to be equal to 0. So we need two velocity values that will be the same, so that when we subtract them, we get 0. And we can see a pair of 7s here, and we can see a pair of 2.4s here. All right. So what that's telling us is that if we were to do an average rate of change, we would have 7 minus 7 over 15 minus 0. That would be 0 over 15, or 0. And here we'd have 2.4 minus 2.4 over 30 minus 25. That would also give us 0. So we're going to say 2 times And that's not a good enough answer because it says we need to justify our answer. All right, because v of 0 equals v of 15, which equals 7, and v of 25 equals v of 30 equals 2.4. And the mean value theorem, and we can say mean value theorem, MVT, will guarantee a zero, or an acceleration, an a of t equal to 0 on both of these intervals since v is both continuous and differentiable. All right, so that's what they're looking for there. All right, for part C, use the data in the table above to approximate the value of v prime of 12.5. All right, so again, this is another average rate of change that they're looking for because we're trying to find the surrounding values of 12.5, so that would be 15 and 10. All right, so v prime of 12.5 will be approximately equal to that average rate of change right there. So now we pull the values from the table. Whoops, I'm off the screen here. I apologize. Let me get that back. V of 15, looking up, I can see is 7, and v of 10 is 9.5. So I have 15 minus 10 there. Now I can use a calculator to go further, but I don't need to simplify, so I can stop right there. I'm looking here. I also do not need units, so I am done. And finally, with part D, this function, f of t, is used to model the velocity of the plane. According to this model, what is the value of this integral? Indicate units of measure. Okay, so let me bring the calculator back in. All right, and I've already, if I go to y equals, you can see the function is right there. So I want to do a definite integral for this, and you have not been taught this yet by me, so I apologize for that. And so we have math 9. Math 9 brings up our definite integral. So we put in the 0 and the 40 and our function, and it comes out to be 236.651. 236.651 miles. So that is how you get part D.